The first learning objective in section 3.1, actually the only learning objective in this section, is to describe the results of the central limit theorem. Which of the following is a true statement about the central limit theorem? For independent observations in a large enough sample, the sample proportion will have the same shape as the original population. For independent observations in a large enough sample, the sample proportion will follow a normal distribution. For independent observations regardless of sample size, the sample proportion will follow a normal distribution. Or for independent observations in a small sample, the sample proportion will be skewed. The central limit theorem is a really important theorem or conclusion in statistics. It tells us that if we take a large enough sample, then the sampling distribution will be bell-shaped, will be normally distributed. So we're talking about the sample proportion here. If we take a large enough sample, then that sample proportion will follow a normal distribution. So the correct answer here is B. This next example says, suppose the true population proportion were 0.95. The figure below shows what the distribution of a sample proportion looks like when the sample size is 20, 100, and 500. What does each point in each of the distributions represent? Describe how the distribution of the sample proportion p hat changes as n becomes larger. So we have, it looks like lines here, but those lines are made up of points. These are graphs that show lots of different results of samples that have these different sample sizes. So the first one here is for n equals 20. The next one is for n equals 100. And the bottom one is for n equals 500. So each of the points that make up these graphs is the result of one sample. So it is a sample proportion. So for example, there were very few sample proportions of 0.7, but lots that were at 0.95, which makes sense. If the true population proportion is 0.95, then we should get samples that are close to that most of the time. Notice that as our sample size increases, a few things change. First of all, we have less space between those stacks of dots there, stacks of points. Because there are more possibilities as we increase our sample size for what we could get for the sample proportion. Also, the shape is changing, and the spread, you can look at the distance from the smallest proportion to the largest proportion. In the first sampling distribution, we have a 0.7 as the smallest, and we have 1 as the largest. But in the next one, it looks like the smallest is 0.85 up to 1, and then in the sampling distribution for samples of size 500, it looks like it goes a little bit bigger than 0.9 up to a little bit smaller than 1. So we're having less variability. Our shape is becoming more bell-shaped and smoother. So let me add in an explanation of what I've just been talking about. So each point represents a sample proportion from a simulation. The distributions become, first, smoother. They look less discrete, less like these separate stacks of points. 2, they have less variability. And 3, they are more symmetric, more shaped like a normal distribution, which is what we talked about in that first multiple choice question. Originally, the shapes were more left skewed, and now they are becoming more symmetric and bell-shaped. One characteristic that does not change is that the balancing point, or the center of all of these distributions, is at 0.95, which is the parameter value for the population. And that makes sense that we should always be centered around the true value.